Okay, today we're going to talk about Pythagorean Theorem a little bit more in depth. Remember, Pythagorean Theorem is a formula that we use to find missing side lengths of a right triangle. Pythagorean Theorem is a formula that is on your star chart, so it's always available to you. Remember that A and B are the legs, so this is a leg and this is a leg, and they're interchangeable, so it doesn't matter what leg is A and what leg is B. The C is always the hypotenuse, so this is the one that has to be the C. Hypotenuse is always the side that is across from the 90-degree angle. So now, for example, if you place a 16-foot ladder, so we're going to have a 16-foot ladder. All right, so this is our ladder. So remember, when you place a ladder up against a wall, it is never straight up and down. It has to be laying on the diagonal. All right, and it is going to be 6 feet from the wall. So there's 6 feet from the wall. This is going to be then our wall. How high up the wall will the ladder go? So we're looking for, right there, we're looking for the height of the wall. How high up will it go? Well, first and foremost, anytime you have a height with the ground, always perpendicular. All heights are perpendicular with the ground. An airplane in the air, whatever it may be, height is perpendicular to the ground. You need to know that because what happens then is that creates yourself a right triangle. You're looking for this leg, you know the hypotenuse is 16 and the other leg is 6. So you use Pythagorean Theorem. And again, A and B are interchangeable. C is always the side across from the 90. So we have A squared plus B squared equals C squared. So x squared, 6 squared is 36. 16 squared is, I believe, 256. Yes, it's 256. Now we're going to subtract 36 from each side. X squared is equal to 220. To get rid of the squared on the x, we have to take the square root of both sides. So that's going to leave us with x is approximately 14.8 feet. So that's how high up the wall the ladder will reach. All right, we can also use the Pythagorean theorem to classify triangles. Remember, when we classify triangles, we're talking about, we're going to classify them based off of their angles. So we can use Pythagorean theorem to classify off of angles. And remember, when we classify off of angles, we're looking for the words acute, obtuse, or right. Those are the ways we classify triangles by angles. So this is the way you use Pythagorean theorem. If the square of the length, if the square of the length of the longest side of the triangle is equal to the sum of the squares of the lengths of the other two, then the triangle is a right triangle. So this is what all that says kind of in just a conditional statement. If, when you square the hypotenuse, it is equal to the sum of the legs squared. So if you the sum of the squared legs, then it's going to form a right triangle. Now, if when you do Pythagorean theorem, c squared is less than the sum of the legs squared, so if c is smaller, then you're going to have an acute triangle. So think about this. This whole idea, this whole concept is piggybacking off of what we learned about angles and sides are all related in a triangle. So remember, the wider the angle is in here, the longer this side is going to have to be to connect everything to make it close up to be a polygon that is then a triangle. And so then vice versa. So this is what we're talking about here, that the angle is smaller, then of course this side is going to have to be short to close everything up in between this angle. So you can see here how the angle and the sides again are related. A small angle equals a short side and vice versa. So if when you perform Pythagorean theorem, c squared happens to be bigger than the others, then what's going to happen is you're going to get an obtuse triangle. So if c squared is larger, the triangle is obtuse. It's not right. So let's look at classifying the triangle by angles. Number 1. So you can notice in number 1, it's just a triangle. We are missing the 90-degree angle. We don't know if it's a right triangle. They want to know if it is or not. So since we don't have a 90-degree angle, we're going to go ahead and make the assumption that the largest piece is the hypotenuse. Okay? Then we're going to go ahead and just assign an A or B to either of the other ones. It doesn't matter. Again, they're interchangeable. So when you're classifying, you're always going to start with squaring the hypotenuse first. You want to know, how does that compare to? Is it equal to, greater than, or less than the sum of the legs squared? So let's check that out. If we square 29, how does that compare to 24 squared plus 16 squared? Okay, now I have a little bit more room to work. So if we square 29, that gives you 841. We still want to know, how is that comparing to the other one squared? So 24 squared gives us 576. And we just said 16 times 16 is 256. So we're going to combine our like terms over here. 576 plus 256 gives us 832. So how does that hypotenuse compare to the legs? The hypotenuse is greater than the legs. So if the hypotenuse is greater than, you're going to form an obtuse triangle. Let's look at number 2. So again, we're not sure which one is the hypotenuse. We're always going to select the largest length as the hypotenuse. Now, since we're given here a number that may be bigger than 6 or 9, we need to check to see what this is. So you've got to plug this in your calculator. 3 square root of 13. So 3 times the square root of 13, and hit enter. And that gives us approximately 10.8. So yes, this happens to be what we're going to test as our hypotenuse. The A and B are interchangeable. So again, we're saying, how does that hypotenuse compare to the legs? So if we square 3 square roots of 13, we're going to square it. How does that compare to 6 squared plus 9 squared? So basically, when this is happening here, this squared is going to cancel out the square root. But you have to make sure and put everything in parentheses in your calculator. So you have to do 3 square times the square root of 13. You're going to close the parentheses and then square everything. And again, your calculator does this for you. All right, it comes out to 117. Again, you have to put it exactly in the calculator like I have it written here, parentheses and all. All right, so 6 squared is 36, 9 squared is 81, so we have 117. How does that compare to? Combine those, so 36 plus 81 is 117. So you can see the hypotenuse is equal to the sum of the square root of the legs, so this is a right triangle. Next, would these squares form a right triangle? If not, what kind? So again, what this is asking is if we were to align the corners of everything, and we put this square here, and we have a square coming off this side. So if we were to line everything up, it's asking, would this in here form a right triangle? If it wouldn't, what kind would then it form? So again, regardless of the diagram or if you have a list of numbers, because sometimes you can see them listed out, like if you have links 6, 5, and 4, all right, sometimes they don't give you a picture, they just give you a list of numbers. So you're always going to choose the largest one as the hypotenuse. So we're going to test 6 squared. How does that compare to the legs squared? So 6 squared is 36. Again, how does that compare to 16 plus 25? How does 36 compare to combined them? 41. So you can see there the hypotenuse is less than the legs. So will this form a right triangle? No, it's going to form an acute triangle.